Imagine that you could travel to the farthest reaches of the universe and see what it will look like in the distant future. What would you find? Would you see stars and planets, or darkness and emptiness? Would you see life and civilizations, or decay and extinction? Would you see hope or despair? The answer depends on how far you go and how much you know. The universe is a vast and beautiful place, full of wonders and mysteries. It is also a place of constant change and evolution. Everything that exists today, from the smallest atoms to the largest galaxies, has a history and a future. And some of these futures are more surprising and extreme than you might think. Stars are the most visible and familiar objects in the universe. They are the source of light and heat for planets, and the origin of most elements that make up matter. Stars are the main actors in the cosmic drama that unfolds in the universe. They create new elements, shape galaxies, influence planets, and sometimes host life. But stars are not eternal. They have finite lifetimes that depend on their initial mass and composition. The more massive stars die first, followed by the less massive ones. As time goes by, fewer and fewer stars are born, while more and more stars die. Eventually, there will be no more gas left to form new stars, and the existing stars will all fade away. This is the fate of the universe, according to the current scientific understanding. The universe will enter a phase of darkness and decay, where the only objects that will remain are the stellar remnants, white dwarfs, neutron stars, and black holes. But even these objects are not immortal. They are subject to various processes that will eventually destroy them. White dwarfs and neutron stars will cool down and become black dwarfs and black neutron stars, invisible and inert lumps of matter. Black holes will slowly evaporate by emitting Hawking radiation, a quantum phenomenon that allows particles to escape from their event horizons. These processes will take an extremely long time, much longer than the age of the universe so far. To give you an idea of how long, let's try to compress the time scale of the universe into something more manageable. Imagine that 1 second represents 120 trillion years, which is roughly the time it will take for the last stars to die out. This means that 1 minute represents 7.2 quadrillion years. 1 hour represents 432 quintillion years. 1 day represents 10.4 sextillion years, and 1 year represents 3.8 septillion years. Now let's see how long it will take for the stellar remnants to disappear. A typical white dwarf will take about 10 circumflex 15 years to cool down completely. On our compressed timescale, this is equivalent to about 8 hours. A typical neutron star will take about 10 circumflex 19 years to cool down completely. On our compressed timescale, this is equivalent to about 3 years. A typical black hole will take about 10 circumflex 67 years to evaporate completely. On our compressed timescale, this is equivalent to about 10 circumflex 50 years. This means that if we start our clock at the Big Bang, the first stars will appear after a few milliseconds, the sun and the earth will appear after about 0.1 seconds, human civilization will appear after about 0.2 seconds, and the last stars will die out after 1 second. Then we will have to wait for about 8 hours for all the white dwarfs to become black, for about 3 years for all the neutron stars to become black, and for about 10 circumflex 50 years for all the black holes to disappear. This is a mind-bogglingly long time, much longer than we can imagine. That's like the universe starting with 1 second of stars and then a billion years of just black holes. Stars are basically the immediate after effects of the Big Bang. A 1 second sizzle of brightness before settling into an essentially endless era of darkness. We live in that one bright second. We are lucky enough to exist in a time when there are still stars shining in the universe, and when there is enough energy and diversity to support life. We live in a very special and brief moment in the cosmic history, and we should appreciate it, because one day, all this will be gone. The universe will become a cold and dark place where nothing interesting or meaningful can happen. This is the ultimate fate of the universe, according to our current knowledge. But is this really how it will end? Is there any hope for a different outcome? Is there anything we can do to change it? Or is there something we don't know yet that could alter this bleak scenario? These are some of the questions that scientists are trying to answer by studying the nature and evolution of the universe. They are looking for clues in the cosmic microwave background, in distant galaxies, in gravitational waves, and in quantum physics. They are also exploring different theories and models that could explain some of the mysteries and puzzles that still remain unsolved. For example, what is dark energy, the mysterious force that is accelerating the expansion of the universe? What is dark matter, the invisible substance that makes up most of the mass in the universe? What happened before or during the Big Bang? What is inside a black hole? And what are the ultimate laws of nature? These are some of the most fascinating and challenging questions that humanity has ever faced. They are also some of the most important ones.